Hello, Professor. So for this week, I chose problem number 13 for homework 2A, and it says two equipotential surfaces surround a positive 1.6 times 10 to the negative 8 coulomb point charge. How far is the 170 volt surface from the 87 volt surface? So for this, I know that it is two equipotential surfaces. So I know that we're referring to a whole circle around this point charge. And I was able to determine that the 170 volt is closest to the charge also by doing the math, but then also just knowing the rules that as you go farther away from the charge, your voltage gets smaller per meter. So 170 volts would be the first distance we are measuring, and then 87 volts would be the second distance we're measuring. So that's how I got that picture. And then our charge is in the center, of course, and that is given this is our charge. So we are given these three things, and it says how far are these 2 points. So we're looking for this distance between these two. And so I know that we have volts, which would be V, our electric potential, and that the SI units for that is volts. So those are the two things that we are given. So I know we're going to be using that. And then we are given charge, which would be Q, with the value of point charge. So this would be Q in here, and that is also given. And then now we're looking for distance. So I know I should use this equation, the electric potential equation, because it includes volts, Q, and it includes our distance, R. Is our distance, and its SI units is M meters. And then also, I know that I can use K because K is a constant. It is electric constant, 9 times 10 to the 9th coulomb, which is just Coulomb's constant. The SI units for this is N, which would be Newton's meter squared divided by C squared, which would be Coulomb squared. So I know so I have to change this equation to be able to get R by itself. So I multiply R to both sides, and then I divide by V to move V over to get R by itself, which would be R equals KQ divided by V. And then I have R, and then now I just plug in all the numbers that I have. So to find the radius, I need to find the radius of each point from this charge. So I have to do it by itself. So I will compare the difference afterwards because I don't know this distance, so I can't just plug in these things. Anyways, so I did first the 170 voltage distance from the charge, and that would be K, Coulomb's constant, times our value of point charge, which was given, and then divided by 170 volts because we're just looking at this distance here. And that distance is 0.847 meters. And then we use try to find our other distance to there, which would be 86 volts. So R equals Coulomb's constant again times our point charge divided by 86 volts. And then that would give us 1.67 meters. And then this also confirms my drawing that that 86 volts is actually farthest away from our point charge. And that does make sense with the laws that we've learned and things like that. So now to be able to get the distance between these two, all I have to do is subtract them from each other. So I would take my farthest distance minus my smaller distance, and I just put R equals 86 volts minus R 170 volts. So then I get R equals 1.67 volts, our voltage distances. So R equals 1.67 meters minus 0.847 meters equals 0.827 meters. And then also I could reverse this in subtracting and also just take the absolute value of this because our distance isn't going to be a negative because we're just looking for distance. So yeah, and that is how I got my distance between these 2 points. Thank you.